Welcome back again. In today's video, I'm going to show you this electricity practical for NECO physics. Okay, now I was able to come up with this based on the apparatus we are asked to provide. If you are just joining this channel for the first time, or this is your first time tuning, don't forget to subscribe to this channel and turn on notifications because we have a lot to gain. With no further ado, let's get right into the video. Now we are asked to provide the following apparatus. This is a resistance box, this is the ammeter, this is a standard resistor label X, that is RX. This is the voltmeter, this is cell, which is the battery, and this is the key. So let me label this. This is the key, and this is what? E. Okay? So we're going to carry out this procedure so you can perform these tasks. I says, measure and record the EMF E of the cell. II, set R to 1 ohm. Close the key. Read and record the current I and the corresponding voltage V. Repeat the procedure for 4 other values of R equals 2 ohm, 4 ohm, 6 ohm, and 8 ohm. IV. In each case, read and record I and V. V. Tabulate your readings. VI. Plot a graph of V on the vertical axis and I on the horizontal axis. VII, sorry. This is VII. Determine the slope of the graph. Then VIII. State 2 precautions taken to ensure accurate result. Now we are going to carry out this procedure the way it is. Now you must remember, one thing that you must note in this connection is this: the positive and negative terminals. This is an ammeter. It has positive and negative terminal. Okay, this is I said everyone has negative and positive terminals. This is a voltmeter that have positive and negative terminals. So in your connection, you must ensure that you connect positive terminal of the ammeter to the positive terminal of the cell. Okay, and also connect negative terminal of the ammeter to the negative terminal of the voltmeter. Now let me teach you how to get the EMF of a cell, because that is the first step. So let's go. Okay. Okay. All right, for us to perform this experiment, I want to show you all the apparatus we have to provide. This is a resistance box. This is the ammeter ranging from 0 to 2 amperes. This is a key. This is a key. Okay. This is standard resistor 2 ohms. This is a cell. Right. This is a battery, right? 1.5 volt. That is 3 volts altogether. Okay. Now this is a voltmeter. What you are going to do, which is the first step, is to measure the EMF from the question provided. We have to measure the EMF of the cell. So how do we measure the EMF? Now I'm going to measure the EMF simply by, see this battery now. This is the positive side and this is the negative side. Okay, I'm going to cover this with a sellotape just to ensure tight connection. Okay, now this is the negative side, so make sure that this metal part is touching this metal part. Okay, I seen it now. Then you now use sellotape and hold them together. That means you have ensured tight connection. Then the next step, or the next thing to do, is to connect positive to positive. Now this is the positive part of the cell, while this is the negative part. So just tap it to this. You just put it like this. Connect positive to positive while you connect negative to negative. Now look at it. If the connection is strong, you can now measure the EMF. If the connection is strong, you can see it now. Positive to positive, negative to negative. Okay, you can see the EMF. Let's read the EMF. What do we have? I have 2.7 volts, right? Can you see it now? So I have to record what I have. All right, so let's proceed with the main experiment. Okay, having measured your EMF, you're going to connect the circuit the way it was illustrated from the question. Okay, But most important thing that you must note is this: how you connect. What is important is how you do your connection, okay? You must connect positive terminal of the cell to the what? To the positive terminal of what? Of the ammeter. Do you understand? Okay, now positive terminal of the cell to the positive terminal of what? Of the ammeter. Do you understand? And also make sure from this resistor, it must be in parallel. Look at it. It must be in parallel connection with the what? With the voltmeter. Do you understand? All right. So now let us start our measurement. Because I must ensure my tight connection, so you must ensure that that is part of your precaution. So I have to use a scotch tape to hold this to make sure that it's tight. Do you understand? So okay, when I close the key, you're going to see a deflection on the ammeter, okay, and also on the voltmeter. Now that is my voltmeter. You can see it now, and this is my ammeter reading. This is my ammeter reading. Now this is when no resistance was removed from the resistance box. So I'm going to record my I naught and my V naught in case I asked to do that, okay? So let me read what I have. For the I naught, remember this one is from 0 to 2 amperes. I'm going to read the one up. Okay, let us take the reading of the ammeter. Look at what we have. Because we have 2 amperes and 5 amperes. So you're reading the one up, right? So I'm going to take the reading for the one up. Now from what I have my I naught is 0.56. This is when this is not taking any reading. Now, how do you know how do you read this? Depending on the ammeter given to you. From here to here is 10 calibrations and it has 0.4. So for you to know what one line stands for, you say 0.4 divided by 10, that is 0.04, right? Then you have to count the number from here to here. This is 10, 11, 12, 13, 14. You can say 0.04 times 14. That gives me 0.56 as my I naught, okay? Now I've recorded that. Let's go to the voltmeter. The voltmeter, I'm reading the one down, which is 0.3 volts. So I have to take what I have here. Okay, this is at 1 volt, 1.00 volt as my voltmeter. That is my V naught. Nothing was removed from the resistance box. Everything is still intact and it gave me this reading. Now we're going to look at the voltage drop by removing the resistance by taking 1 ohm, 2 ohm, 4 ohm, 6 ohm and 8 ohm. Let's see what will happen to the voltmeter reading and the ammeter reading. All right. Now the question says set R to 1 ohm. We are going to remove 1 ohm from the resistance, but look at 1 ohm here. Just remove 1 ohm. Okay, that's all. So let's look at the voltage drop and the reading on the ammeter. We have removed that. There is a change in the ammeter reading. What do we have? Okay, let's calculate. Remember, one line stands for 0.04 and this is at 11 now. So 0.04 times 11. I'm having 0.44. 0.44. So you have to record that. Let's go to the voltmeter. Okay, the voltage dropped to 0.9. okay, so I have the voltage up to 0.9. So I have to record my voltage to be 0.9 volts. Do you understand? Now let's continue again by setting the resistance to be 2 ohms. Look at it. We are going to replace the 1 ohm, okay, and remove at what? 2 ohm. Let's see what happens. Can you see? It's reducing. So what do I have? Okay. Remember reading the up part. I have 8. I just have to multiply. I'll say 8 times 0.04. That gives me, when resistance is 2 ohm. When resistance is 2 ohm, okay, my ammeter reading is 0.32. Hope you are getting it. All right, let's look at the PD on the voltmeter. What do I have? It's going down. I have 0.6 volts. But look at it now. This is 0.6 volts. So I have to record it. Now look at it. You see it's actually dropping. Let's move to the next one. By taking resistance to be 4 ohm. If we want to take 4 ohm, what I'm going to do is I've already removed 2. I'm going to remove another 2 to making it what? 4. So just remove 2. Okay? Making it 4. Now, let's check out the reading on the ammeter. It's still dropping. I have 6. Looking like in between. Okay, I have 6. So I'm going to say 6 times 0.04. That gives me, when the resistance is 4 ohm, this is going to give me 0.24, right? Okay, so let's go to the voltmeter. What do we have? We have 0.4 volt. So we have 0.4 volt. You can see that this one is 0.40 because I want it to be in 2 decimal places. That is why I'm adding what? 0. All right. So let's move to the next one, which is setting it to be 6. If I want to set it to be 6, I'm going to replace this 2. That is making it 4. Now, for me to set it to be at 6 ohm, I'm going to remove 1 and equally remove what? 5. Can you see it now? Okay, so let's check what we have. What is the ammeter reading? It's giving me 5. So I have 5 times 0.04. That is 0.2. So when this is giving me at 6, resistance is 6. I have my ammeter reading to be 0.20. So let's go to the voltmeter. The voltmeter reading gives me, voltmeter reader is still giving me the same thing as 0.40. So I have to record what I have. 0.40. There is no difference here. The same thing as the voltage as this. So let's look at the last one, which is at 8 ohm. By doing 8 ohm, I already removed 1 and 5. So I'm going to remove extra 2 to making it what? 8 ohms. So let's see the reading on the what? Current. So what do I have? I have this at 4. So I will say 4 times 0.04. So at 8 ohm, I have 0.16. So the voltage drop, the voltage is at 0.3. Okay, so the voltage is at 0.3. So let me say the voltage is at 0.3. Now we have completed this. This is what we have. So I'm going to use it to plot our what? Graph. This is a reading gotten from this electricity practical number 3. Okay, so if you can look at it now, there is a change here as the resistance is being increased on the resistance box. There is a decrease in the ammeter and equally a decrease in the voltmeter. Okay, now the decrease is not much, just slight decrease. So from the observations gotten, we are expected to carry out the following exercise. Plot a graph of V on the vertical axis and I on the horizontal axis. So we are going to plot a graph and find the slope of the graph before looking at the precautions taken to obtain accurate results. So let's go. By plotting the graph, we are going to draw our line. Okay, now look at what we have. We have this reading, so we're going to choose a very good scale. Now, this is V axis measured in volts, while this is I measured in amperes. Okay, now this is my 0. So let me write the title of the graph. A graph of V measured in volts against I measured in amperes. Okay, all right, so let's use a very good scale. We're going to use from what we have. Let's assume there is no 0 here. Let's see the whole numbers here. This is 3, 4, 4, 6, 9. So we can increase it in interval of 0.1. Okay, the same thing is applicable to this place. So I'm going to say scale is equals to 2 cm to 0.1 unit on V axis. Okay, then here again 2 cm to 0.1 unit on ampere axis, right? So let's just put in our values. This is 2 cm, okay? From here to here is 2 cm. Now this is 0.1, 0.2, 0.3, 0.4. Then we label it to the end, okay? Now to this axis, I still have 0.1, 0.2, 0.3 to the end, right? Let us put in our values. The first one we have 0.90 on the volt axis as against 0.44. So this is 0.90. Okay. Now this is here 0.4. Okay. Now coming from here to here, I have 0.1. That is 2 cm, which comprises 10 lines. Okay. What does 1 stand for? That is 0.1 divided by what? By 10 is going to give me 0.01. So each line increases by 0.01. So this is 0.01, 0.02, 0.03, 0.04, 0.05, 6, 7, 8, 9, 0. What? 1. 0.11, 12, 13, 14, 15. Okay, so coming to this place, this is 0.40, 0.41, 42, 43, 44, right? At against 0.9. So let us trace it and see their meeting point. Make sure you confirm it. See their meeting point, you put a what? You put a dot, right? Now coming to the next, 0.60 against 0.32. This is 60 against 0. This is 3, 31, 32. So I'll go this way. You can see it now. Coming to the next one, 0.40 at against 0.24. Okay, the next one is 0.40 at against 0.24. So this is 0.40, okay, on the vertical axis at against 0.24. Now this is 0.20, 21, 22, 23, 24. Okay, so let's go. Now this is 0.40 against 0.24. You put a dot. You can see it now. So the same way we'll continue and put all the points. So let's go. Having plotted the points, I'm going to join the line. Okay, line of best fit, and find the slope. And look at it. I have 2 points that's going to enter this line. Okay, while the rest of the points, one is here, one is here, and one is here. Let's see another form of it. I have 3 points, but the 2 points are on one side, so it can be considered to be a line of best fit. Okay, so I'm going to change it to be this way. This can actually go. Look at it, it can go. Now one on this side, one on this other side. It can go. And this can equally go too, depending on how you arrange it. So but then let's just draw what we have. Now look at it. Let us find the slope of the graph by choosing a large triangle. Having drawn the triangle, this change in V against change in what? I. Now I can take it down on the axis. Now I can take it here too. Okay. Now come to this side. All right. So this is my I1 and this is my what? I2. While this is my V1 and this is my V2. So we are done with this graph. So let us find the slope. The slope is equals to change in V over change in I. Note that the V, which is potential difference, is measured in volt, while current is measured in amperes. So this is equals to V2 minus V1 divided by I2 minus I1, right? Now look at for the values. I have we have this is 1.01, 1.02, 0.03, 0.04. So this is 1.04 minus 0.34, 0.3 what? 4, okay? Then divided by this 0.56, 0.56 minus this 0.18, 0.18. So let's work it out to see what we have. 1.04 minus 0.34. So we have this to be 0.7 divided by 0.56 minus 0.18. So that gives me 0.38. So let's just divide 0.7 divided by 0.38. So that gives me 1.84, right? Now that is my slope. Now this is measured in volts per amperes. Okay. Now this is what? This is my slope. What is the significance of this slope? They might ask you. You know, we have an unknown resistance, label X, Rx rather. Now, using Ohm's law, we say Ohm's law, V is equals what? IR, right? And we plotted a graph of this against what? This. So that means we plotted a graph of V against what? I is now equals what? My R. And my R is now my slope. And my slope is 1.84. Okay. Now this is significant to the unknown resistance given in the question, which is what? 2 ohm. So my slope is approximately what? 2 ohms. Because this is 1.84 volts per amperes or what? Ohms. In case you are asked, what is the significance of the slope gotten? It means what? The unknown resistance, which is what? 2 ohms. Do you understand? Alright, so these are some of the precautions taken while performing this experiment. Number 1, I ensured tight connection, very, very important. Number 2, I avoided parallax error while reading the voltmeter and ammeter. Okay. Number 3, I ensured I opened the key when no reading is being taken. You make sure that the key is open when no reading is being taken. So these are the sum of precautions you need to know. They're going to ask you to state only 2. So pick any one of your choice that you can remember on that day. You may be asked to state 2 advantages of connecting identical cells in parallel, okay? And also to state 2 factors to consider in choosing a material for the design of a resistor. So you should know that and practice all those things in case you see it. Now, if this video was able to help someone out there, please don't forget to subscribe to this channel and turn on notifications to get notified each time I post videos. And lastly, do not forget to share so that other students that are preparing for this same forthcoming exam can see and learn from there. See you next time in the next one. And hold on for my number 2. Bye for now.